Welcome to A-Level and AP Physics. In today's lesson, we will discuss some important past paper questions on electricity from May-June 2022, Paper 1, Variant 1. In this lesson, we will discuss these questions in detail so you can improve your conceptual understanding of this topic. Let's study together, let's improve together. For question number 31, it is given to us a straight copper wire of diameter 0.42 times 10 to minus 3 meters has a number density of free electrons of 8.5 times 10 to 28 per cubic meter. In a given time interval, a charge of 0.15 coulombs moves through the wire. What is the average displacement of the free electrons along the wire in this time interval? This question is simply about transport equation. Transport equation is simply I is equal to NQ VA. We need to calculate in this case average displacement. In order to calculate average displacement, we can replace I with Q over T and we can write down Q over T is equal to NQVA. Q is the total charge and this Q is the charge on single electron. So you cannot cancel this Q with this Q. These are two different Qs. From here we can write down capital Q. This is equal to NQA V times T, but velocity times time, this is equal to displacement. So we can write down Q is equal to NQ A times displacement. So S is the displacement and we need to calculate displacement. So we can say S is equal to capital Q divided by NQ times A. Q is the total charge, that is equal to 0.15 coulombs. N is the number density, that is equal to 8.5 times 10 to 28 per cubic meters, means number of free electrons per cubic meter. And Q is the charge on single electron, or we can say this is the charge on single charge carrier, 1.6 times 10 to minus 19 coulombs. Times cross-sectional area, diameter is given to us. So we can say this is pi by 4 d square. D square, so we can multiply with 0.42 times 10 to minus 3 square of this. And now if we solve this one for S, our final answer will be equal to 8.0 times 10 to minus 5 meters. So this is the answer. So this is what you need to calculate, and this is the average displacement of free electrons in given time interval. So our answer for this question is C. For question number 32, we need to find out what is definition of the potential difference across a component. Potential difference simply is equal to work done per unit charge. Work done per unit charge, or simply we can say this is the energy transfer to the component per unit charge. Per unit charge. So this is how we can define potential difference. It simply means that when unit charge passes through a component, how much energy is transferred to the component. If we talk about resistor, in case of resistor, when unit charge passes through resistor, how much electrical energy is converted into thermal energy. That is potential difference. Let's try to find out what is the best possible option. If you look at option A, it is given to us electrical power supplied to the component. This is incorrect option. But if you look at option B, it is given to us this is energy transfer to the component per unit charge. So this is our answer. So this option is correct. For option C, it is given to us the product of current in the component and its resistance. This is not definition of potential difference. For D, it is given to us voltage across the component. This is not how we define potential difference. So this is also incorrect definition of potential difference. So the answer for this question is B. We need to understand how we define potential difference. So this is how potential difference is defined. For this question, it is given to us the graph shows the IV characteristic for a semiconductor diode. Which statement can be deduced from the graph? This question is simply about understanding of this graph. If we have clear understanding of this graph, we can answer this question very quickly. Let's try to understand a little bit about this graph first of all. If you look at right side, we can see with the same increase in potential difference, increase in I is getting bigger and bigger. So simply we can say in this case resistance is decreasing, because resistance is the ratio between potential difference and current passing through resistor. In this case we have diode. So for the same increase in potential difference, if the increase in I is getting bigger and bigger, it simply means that resistance of the component is decreasing. So this side resistance is decreasing with increase in potential difference. But on left side, the resistance is very high because increase in current is very little, almost there is no increase in current. So we can say resistance is very high on the left side. Actually this is called forward biased. So this is forward biased, and this one is reverse biased. This one is reverse biased. Now we have some understanding of this graph. Let's look at given options and try to find out the best possible option. If you look at option A, it is given to us above a certain positive potential difference, diode obeys Ohm's law. This is incorrect. If this diode obey Ohm's law, then V and I, they have to be directly proportional. So this one is incorrect. Option B, current is directly proportional to potential difference. This is also statement of Ohm's law. This is also incorrect. If you look at option C, it is given to us diode as zero resistance when current in the diode is in one direction. Resistance will be zero when current is infinite. Means when current is infinite, resistance will be zero. But current is not infinite. So option C is also incorrect. For option D, it is given to us the resistance of the diode depends upon potential difference across it. And this one is true. As potential difference is increasing, resistance of diode is decreasing. So it simply means that resistance of diode is depending on potential difference across diode. So our answer for this question is D. So very important point about diode, you need to understand resistance of diode depends upon potential difference across diode. So our answer for this one is D. For question number 34, it is given to us a wire has a resistance of 30 ohms. A second wire is made from the same material, has the same mass, and is 3 times as long as the first wire. What is resistance of the second wire? So in this case, we can imagine that, let's say we have one wire, this is wire A, and the second is wire B. For wire A, it is given to us the resistance of wire A, we can simply say this is RA, and the value of its resistance is given. So we can also say resistance of wire B, let's say this is RB. They are made of the same material, means the resistivity of these two wires is the same. Resistivity is the same, have the same mass. If they have the same mass and density is also the same, so it means that volume also is the same. For the first wire, it is given to us has the same mass and is 3 times longer. For the first wire, let's say the length of first wire is L. So the length of second wire, this one will be 3L. Now let's say the cross-sectional area of wire A is capital A. So what is cross-sectional area of second wire? But in this case, mass is the same, density is the same. It means the volume of wire A has to be equal to volume of wire B. Volume of wire A, we can simply write down, this is A times L. And the length of the second wire is 3L. So the cross-sectional area of this wire has to be equal to A by 3. So we can write down this is A by 3. Now in this case, we need to find out resistance of second wire, means resistance of RB. We can write down resistance of RA. Resistance of RA will be equal to rho L by A. So the resistance of RB, we can say this is rho. L is equal to 3L and cross-sectional area is A by 3. If we simplify this, we can say this is rho L divided by A, and we have here 3 multiply by 3. So in this case we will get, here we will get RA, because this is equal to resistance of wire A times 9. So this is RB. So simply we can write down here now, resistance of wire B is equal to 9 times of resistance of wire A. 9 times resistance of wire A. Resistance of wire A is given. So if we simply multiply, our final answer will be equal to 270 ohms. So this is resistance of wire B. So this is how you can approach this type of problem. You need to understand the technique, the method we use. So the answer for this question is D. For question number 35, it is given to us a cell has internal resistance small r and electromotive force capital E. The cell is connected in series with an ammeter and a variable resistor of resistance capital R. When R is equal to 10 ohms, the ammeter reads 0.3 amps. When R is equal to 5 ohms, ammeter reads 0.4 amps. What is value of E? So for this question, we need to find out value of E. In order to find value of E, we can consider first of all when I is equal to 0.3 amps. So we can write down E is equal to I current in the circuit plus load resistance plus internal resistance. We need to find out value of E. I is given, that is equal to 0.3, and value of R is given, that is 10, and value of small r is not given. We can also rewrite this equation when current is equal to 0.4 amps. So we can rewrite E is equal to I current in the circuit times load resistance times internal resistance. In this case, current is equal to 0.4 amps as it is given here. Load resistance is equal to 5 ohms and internal resistance is not given. We can say this is equation 1 and this is second equation. In this case, these two equations are equal because E is equal to this and also E is equal to this one. So simply in this case, we can equate 1 and 2. So we can say 1 is equal to 2 by equating equation 1 and 2. Equation 1, 0.3 times 10 plus small r, this one is equal to 0.4 times 5 plus r. If we multiply this one inside, we will get 3 here plus we will get, this is 0.3 times r, and if we multiply this one inside, in this case we will get 2 plus 0.4 r. From here we can get value of r. So r will be equal to, in this case r will be equal to 3 minus 2 divided by 0.1. So simply we will get r is equal to 10 ohms. So this is value of internal resistance. R is equal to 10 ohms. Now we have value of R, we can use any equation and we can find out value of E. Let's try to find out value of E using equation 2. According to equation 2, E is equal to 0.4 times 5 plus R, but R in this case is equal to 10. So we can write down 0.4 times 5 plus 10. Now we can simplify. This is 0.4 times we have 5 plus 10, so this is equal to 15. If we multiply this inside, we will get value of E. This is equal to 6 volts. So the value of E is equal to 6 volts. And our answer for this question is D. So this is how you can approach this type of problems. This is also kind of typical question. You need to understand how to find internal resistance and how to find EMF of battery. Very nice question. You need to get very clear about this type of problems. And this is how you can answer this type of questions.